boys and girls, welcome to Hexili Maths class. Well, my name is Lim Hui Jing. You may call me Madam Lim or Pon Lim. Are you ready to learn the lessons today? Today, I'm going to introduce you by using Levy techniques in finding area between two curves for the applications of definite integral. How to relate with area of rectangles? If we divide the regions of area on the two curves into n small rectangles as shown above, we know that the area is approximately to the total area of n rectangles. By taking a piece of rectangles, we denote the shorter side with width and the longer side with length. Use the rectangle's areas, length and width to form the integral formulas for areas. Look at the integral formula of area between curves. The length of the rectangle is the function fx minus gx, and the width of each rectangle is dx. The integral sign is the Riemann sum. As we take the limits as n approaches infinity, we have total up the area of the rectangles, and AB is the x boundaries. How does Stanek-Lewis works? Let me explain to you. With only 3 simple steps, we can find area between two curves. Step 1. We locate the Levy block vertically or horizontally on the shaded region. Step 2. We decide the function length and width. Step 3. We write the formula area in the integral form of length times width. To make it clearer, let me illustrate through this diagram. Step 1. We locate the Levy block on the shaded region. The block is located vertically when you choose x boundary. Meanwhile, it is located horizontally if you choose y boundary as the limit of integration. Remember, length is longer than width, so we label the longer side as length and the shorter side as width. Step 2. We decide the function length and width. For the vertical block, we have two functions. They are fx and gx. Length awaits the upper functions, subtract with the lower functions. Therefore, we have the length as fx minus gx. Width is the small changes of x, which is dx. For the horizontal blocks, we have the function fy and gy. We always taking right functions subtract with the left functions for the length. That is, the length will be have the fy minus gy, and the width is the small changes of y, that is the dy. Step 3. We write the formula in the integral form. For the vertical blocks, we have the integral of length times width with the function fx minus gx and integrate with respect to x. And for the horizontal block, we have the integral of the length times width also with the function fy minus gy integrate with y. As the conclusions, we can say that there are two cases to be considered. Case 1 with the vertical Levy block with the integration with respect to x, length is the upper function, subtract with the lower function, and width is the small changes of x. Case 2 with the horizontal Levy block is the integration with the respect to y. Length is the right function, subtract with the left function, and width is the small changes of y. Let me show you with these two examples. Case 1, we use the vertical Levy block for the x boundary. So step 1, we locate the Levy block vertically. Step 2, we decide the function length and width. So length as the upper function, subtract with the lower functions, width is the dx. Step 3, so we rewrite the formula's area in the length times width. After that, we start to integrate and get the answers for area. Case 2, we have the horizontal levy block of the y boundary. Step 1, we locate the levy block horizontally. Step 2, we decide the function's length and width. Length is the right function, subtract with the left function. Width is dy. Step 3, we rewrite the formula area in length times width. After that, we integrate functions in respect to y and evaluate to get the areas. You may scan the QR code, so do some practice in levy worksheets. After that, you may check the answers in the step-by-step solutions worksheets. Finally, do remember to leave us a positive feedback. It comes to an end. Thanks for watching. I hope you will find these levy techniques is useful.